Hi everybody, in this video let's talk about equivalent transformation. In the previous video I shared with you about the commutative law in combined transformation. Still remember, if I have a combined transformation PQ, I want to determine whether this combined transformation PQ satisfies the commutative law or does not satisfy the commutative law. What do I need to do? I need to draw the image for PQ and QP. If both of them produce the same images, I can say that this combined transformation PQ satisfies the commutative law. Okay, in this situation, PQ and QP, they produce the same images. We also can say that PQ and QP, they are equivalent. Okay, so sometime in the exam, it will give you a combined transformation PQ, for example, and it asks you to determine a single transformation which is equivalent to PQ. What does this mean? It means that we're going to determine a single transformation which is going to produce the same image as the PQ does. Now let's look at this example. In the diagram, triangle P is the image of triangle R. Okay, triangle P is the image of triangle R under a transformation V. From here, go here. The transformation involved is V, while the triangle Q here is the image of triangle P under a transformation W. Okay, so the first part we need to describe in full the transformation W and V. So from here we know that the transformation involved will be rotation, right? To describe a rotation, we need to mention three things. Remember, the angle of rotation, direction, and the center of rotation. Okay, so let's find out the center of rotation first. Before I start to determine the center of rotation, let me label all the vertices first, so easier for you to follow me. Okay, let me label this one as A, as B, this is B, and this is C. So here will be A prime, B prime, and C prime. Okay, so this will be A double prime, B double prime, and C double prime. Let's determine the first transformation first, which is V. To get the center of rotation, we need to construct two perpendicular bisectors. Still remember? So we need to choose two pair of corresponding vertices. So you can use A prime and A, then C prime and C, or B prime and B. We just need two pair. So here I'm going to use A prime and A first. I want to construct a perpendicular bisector of A prime and A, which is somewhere around here. Okay, draw an arc over here. Do the same thing here. Move your compasses, place the needle of the compasses over here, A, and don't adjust the width of the compasses, keep the same width. Okay, do the same thing over here. Next step is just to connect these two intersection points together. One perpendicular bisector is not enough for us to get the center of rotation. We need another pair. So you can use B prime and B or C prime and C. In this situation, I'm going to use B prime and B. Because to construct the perpendicular bisector of B prime and B, we don't need the compasses. This is horizontal line. You want to break it into 2 equal half, you just calculate. 1, 2, half will be 1. Okay, so draw a line over here. The intersection point of these two perpendicular bisector is over here. So this is the center of rotation. 4, 1. Next thing is to determine the angle of rotation and also the direction. 1, 1. So this is B, right? So I need to draw another L shape, go to B prime, from the center, go to B prime. 1, 1. So from here, you know that this is an anti-clockwise rotation of 90 degrees. About the point 4, 1. V is an anti-clockwise rotation V is an anti-clockwise rotation about, anti-clockwise rotation of 90 degree, about the point 41. Okay, so make sure we have mentioned three important information: angle, directions, and the center. Okay, so this is the way how we describe a rotation. Next, let's determine the center of rotation of the transformation W. Okay, first we take out our compasses. Same as what we did just now, we need to construct two perpendicular bisector. We need to choose two pair of corresponding vertices. So how about I use A prime and A double prime. Construct perpendicular bisector here first. Okay, give the same width. Place the needle of your compasses over here, A double prime. Do the same thing. Connect these two intersection points together. Okay, so one perpendicular bisector is not enough. We need to construct another one. So you can use B prime and B double prime, or C prime and C double prime. So in this situation, I'm going to use B prime and B double prime is because it's easier. This is vertical line. So we want to construct a perpendicular bisector. We can just calculate. Don't have to use our calculator. Don't have to use our compasses. 1, 2, 3, 4. Break it into half will be 2. 1, 2. So we need to draw a line over here. Okay, so you will see the intersection point between these two perpendicular bisector is over here. So this is the center of rotation of transformation W. One, 0. Next thing is to determine the angle of rotation and the direction. 1, 2. Okay, 1, 2. From here, go here, 90 degree clockwise. W is a clockwise rotation of 90 degree about the point 10. Okay, so this is the way how we describe a rotation. Next thing, state a single transformation that is equivalent to WV. So WV, be careful, this is the first one, which is here, V, and this is the second one, second transformation. From here, go here, W. Okay, so we are going to determine a single transformation which will produce the same image of R, which is over here, Q. So from here, directly go here. So by observing these two shapes, we know that the single transformation, which is equivalent to WV, is actually a translation, right? From here, translated to here. So to describe a translation is actually very easy. From here, go here. Let me calculate how many units go to left and how many units go down. 1, 2, 2 unit. 1, 2, 3, 4, 4 unit. Okay, so the equivalent transformation of WV will be translation. Go to your left, -2, go down, -4, -2, -4. Okay, so this is the equivalent transformation of WV. That means WV and translation -2, -4, they will actually produce the same images. Okay, that's all for this video. Thanks for watching. See you next time. Bye bye.